Hello students, in this video we'll understand the law of universal gravitation. Gravitation, you must be listening this word since your childhood. Gravitation, Isaac Newton, apple falling on the head of Isaac Newton. So what actually is gravitation, that we'll try to understand in this video. Okay, so first we'll try to go through the definition of the gravitation, the law of universal gravitation. We see that it is written that Newton's law of universal gravitation states that every particle attracts every other particle in the universe. That means, first of all, till well, we'll try to understand till here. So what it states that every particle in the universe attracts every other particle in the universe. Okay, so let us suppose that there is a particle over here, okay, and there are so many particles around surrounding this particle. Okay, now this particle will attract each and every particle surrounding this particle according to the law of universal gravitation. That means in this universe all the particles attract each and every other particle around it. Okay, now that the force with a force that is directly proportional to the product of masses and inversely proportional to the square of distance between them. Now according to the law of universal gravitation, any two body in the universe attract each other. Now they attract each other with a force. Now that force is directly proportional to the product of that masses and inversely proportional to the square of distance between them. Now let us understand it through a diagram. Okay, let us suppose there is a body A and body B. Okay, the mass of body A is m1 and the mass of body B is m2. Okay, now the distance between the two bodies is taken as r. Now you see that the distance which we have considered it from the center of the bodies. Okay, now just taking distance doesn't mean you will take a distance from anywhere, from here to here. No, you have to take from the center of the body, or the point where the center of the mass of that body exists. Okay, now you see that according to the force of the law of universal gravitation, the force of gravitation, which is denoted by Fg, is directly proportional to the product of masses. Now this Fg is directly proportional to m1 into m2. Okay, now according to the same definition, the force of gravitation Fg is inversely proportional to the square of distance between them. That means Fg is inversely proportional to r square. Now, if we combine these two equations, what we get, that the force of gravitation is directly proportional to m1 m2 by r square. Now what we get this formula. Okay, now if we'll try to remove the sign of proportionality, we'll get a constant of proportionality. That means we'll get Fg, or the force of gravitation, is equal to g m1 m2 by r square. Now this g is a constant of proportionality. Now the constant of proportionality that we get here in this equation is called g and is denoted by capital G. Okay, now do not confuse between the small g and the capital G. There's a vast difference between the small g and the capital G. The small g represents the acceleration due to gravity and the capital G represents the universal gravitation constant. Okay, now this capital G is called universal gravitation constant, and the value of G is 6.673 into 10 to the power minus 11 Newton meter square per kg square. And it was determined experimentally by Henry Cavendish. So the value of G, because as we know that this G is nothing but a constant of proportionality, so this is a constant, that means its value will remain fixed, and its value was found experimentally by a scientist named Henry Cavendish, and the value of G was found to be 6.673 into 10 to the power minus 11 Newton meter square per kg square. Okay, now you must have understood the definition and the mathematical expression, but let us understand it through one example, example related to the numerical. Okay, now you see that the example given here is, determine the gravitational force between two bodies if two masses are 30 kg 50 kg separated by a distance of 4 meter. Now according to question, there are two masses of 30 kg and 50 kg and they are separated by a distance of 4 meter. What do we mean by separated by a distance of 4 meter? That the center of the bodies of those two, body A and B, is separated by 4 meter. Now m1 is equal to 30 kg, m2 is equal to 50 kg, and r is equal to 4 meter. Now the value of the universal gravitation constant G is generally given in every question, but if it is not given also, you should remember this the value. Okay, the capital G is equal to 6.673 into 10 to the power minus 11 Newton meter square per kg square. Now the force of gravitation formula is G m1 m2 by r square. Now putting the values of the G m1 m2 by r square, we get 6.673 into 10 to the power minus 11 into 30 into 50 by r square, that means 4 square, that is 16. Now if you try to solve the equation mathematically, if I'm using a calculator, you will get this value 625.5 into 10 to the power minus 11 Newton. Okay, now this is the final answer. Now you must be thinking that how this Newton came. Okay, now obviously you will be thinking that obviously the force is force of gravitation is to be found out, and gravitation is a force, and the unit of force is Newton, so of course the Newton should come. But why Newton came, why capital, and why not some other value or some other symbol? Okay, now as we have calculated the numerical value, in the same way we have to calculate the symbol circle also. Now you see that the value of G is Newton meter square by kg square. Here we have, here it is given, and into m1 into m2 kg square by r square, that means meter square. This meter square cancels, this kg square cancels. What we get? Newton. So the answer of this question will be 625.5 into 10 to the power minus 11 Newton. And you have understood both how we got the numerical value and how we got the symbol. Okay, now I think so you must have understood this mathematical expression of universal gravitation law and the definition and also the numerical. Now we must understand, we must try to understand the application of the law of universal gravitation. Now this law helps us to understand many of the daily life phenomena that are taking place around us in the environment. Like so bodies falling towards the earth is they fall because of the gravitational force of the earth. Suppose an apple falls towards the earth. It is very famous story that an apple fell on the head of the Sir Isaac Newton, and he thought about the gravity. So we'll take the same example. Okay, that when an apple falls towards the earth, or anybody falls towards the earth, it falls because of the force of gravitation. That means due to the universal gravitation law, earth attracts it. Okay, now you must be thinking that one more example we have, even from the smaller bodies falling towards the earth, even all the larger bodies like the heavenly bodies like planets, suns, they all also attract each other. Even they all attract us also. Okay, so like the earth attracts the moon. Now you must be thinking that when the earth and the moon attracts each other, why not the moon is pushed or pulled towards the earth? Why doesn't it come near the earth and get it stick towards it? No, why does it this not happen? Because you know that when, suppose this is earth, okay, and moon is revolving around the earth. Okay, now when the moon is revolving around the earth attracts the moon, and a force is acting towards the earth on the moon. Now this force is centripetal force. You know that when a body has to be moved in a circular motion, there has to be a centripetal force. It is a necessary condition for the body to be in a circular motion. Okay, so we know that when the moon revolves around the earth, there is a centripetal force acting towards the earth. Okay, and that centripetal force is nothing but the force of gravitation. Now one more force is acting on this body, that is the centrifugal force. What is centrifugal force? It is a force that acts on the body moving in a circular motion perpendicular to its direction of motion. So suppose if the body is moving in this direction, the centrifugal force is perpendicular to the motion. Now you see that the centrifugal force and the centripetal force are in opposite direction. You can easily say the centrifugal force is towards the center of the body and the centrifugal force is away from the center of the body. But the amount or the magnitude of both the forces are same. So centripetal force and centrifugal force are same in magnitude and direction. Okay, that's why the moon doesn't get pulled towards earth and it keeps revolving around the earth. So I think so. You must have understood the law of universal gravitation, the mathematical expression, defining the gravitation formula, and you also must have understood by a numerical and the applications. So I think so. Gravitation, the basic. This is fundamentals of gravitation. This I think so. Every student must know. After understanding this, only you can go further in the gravitation chapter. So I think so. You must have probably understood it, and if you like this video, kindly share, subscribe, and like, and also comment. Do comment in the comment box if you have any doubt regarding any chapters in the physics. If you want to have any lecture on any particular topic in the physics, so I'll try to take that lecture, or I'll also try to make a video and post it on the YouTube. So this is for today. I'll see you in the next video. Thank you.